Okay, I think you may start now.
Good evening to Dr. Puzaring and Ms. Chen Sanford. So we are from Group A and we present about sewage treatment plant to produce biogas and generate electricity. Next. So this is our group member. First, Nur Azwana Ariana binti Ibrahim, Nur Hazmira Putri binti Hazmi, Agnita Miranda, and me, Nur Sofia Akila. Yes. So, for our plan objective is first, the biggest produced from anaerobic digestion of sewage can be used to generate electricity and heat, so providing a renewable energy source that reduces reliance on fossil fuels. Second, by converting sewage into biogas, the plan significantly reduces the volume of waste and supports sustainable practice. Treating sewage ensure that water discharge into natural water bodies such as Sungai Pegalan, which is meet environmental standard, protecting local ecosystem. Next. So for the market survey potential client, so our product we will produce electricity from biogas, and our second product is fertilizer. So SES could be a strategic client for purchasing electricity from our plant, and farmer and plantation owner for purchasing fertilizer. So by selling electricity to SESB can provide a stable and long-term revenue stream for our biogas project. SESB, which is a need for reliable power sources, make them a dependable client, because SESB currently have a shortage for now. SESB currently relies heavily on their independent power producer IPPS for about 80% of its electricity supply. So, which is this create opportunity for us, which is a new reliable source of energy to diversify their supply base. So, their IPPS, which is Kimanis Power Sdn Bhd and Renhil Powertron 2 Sdn Bhd, provide the Sabah system with 155 megawatts of electricity. So, for 2024, SESB at least 70% of Sabah baseload power requirement to ensure stability and reduce power disruption, with the current maximum power demand at 1,200 megawatt and reserve margin of less than 20%. There is a clear need for additional stable and power source. So, based on our calculation, our plan will produce 5,397.08 kilowatt hour of electricity per day. So, next. So this is our potential competitor. So like I mentioned just now, IPPS, Kimanis Power Sdn Bhd and Renhil Powertron 2 Sdn Bhd already have established infrastructure and long-term power purchase agreement with SESB. So since our product is our second product is fertilizer, so our competitor for fertilizer market is Yara International SA. Nitrogen-based fertilizer, ammonia, and other industrial products. Local producer, which is numerous local and regional fertilizer producer cater to specific agriculture needs in Sabah. This company often have strong relationship with local farmer and plantations. Then organic fertilizer. There is an increasing demand for organic fertilizer due to their environmental benefit and the growing trends towards sustainable agriculture. Next. Wait. Okay. So, wait. This is our proposed location for our plant in the yellow block 1. So the coordinate which is 5.32899.116.157895. So this site was carefully picked since it is accessibly close to resource and rivers. So for sewage supply, we will do a collaboration with sewage treatment plant Keningau, which is nearby, and the release treated water. We will release treated water to Sungai Pegalan. So why we choose this location? So to reduce pipeline cost, because when the supply base and the place for we discharge our treated water, we don't need to put a lot of cost for pipeline. So I will pass to next person.
Okay, Assalamualaikum and good afternoon to our assessor. So for process and technology selection for biogas production, there are two available process which are anaerobic digestion by biodigester and also pyrolysis of sewage sludge. Anaerobic digestion is a process of biodigester breaking down waste anaerobically in a state of no oxygen and producing biogas for energy use. And there are three configurations that are available for biodigester, such as UASB, ANMBR, and also EGSB. And for pyrolysis of sewage sludge, pyrolysis is process of heating sewage without sludge at 350 to 700 degrees Celsius and producing biogas and biochar as its byproduct. And there are three available reactors such as fixed bed reactor, fluidized bed, and also rotary kiln. For electricity generation, there are two technology which are CHP, which is combined heat power, and also fuel cell for biogas. CHP system uses biogas to generate electricity and heat, and it is efficient energy recovery by simultaneously producing power and thermal energy. For fuel cell biogas, fuel cell converts biogas directly into electricity through electrochemical reactions, which may be highly cost compared to CHP technology, and it is efficient energy production with minimal emissions as compared to combustion method. Next, moving on to our selected process and justification. So we evaluated the process based on its cost effectiveness, sustainability, and also efficiency. So we have selected anaerobic digestion by UASB. From among the three configuration, UASB was selected due to its cost. As compared to ANMBR and EGSB, it is more cost effective, and it consumes less energy and relies on natural biological processes with lower capital and operational costs. UASB is the most cost effective, and although may not be the most efficient biogas generator, it nevertheless does a enough job of treating wastewater and sewage while reducing running costs and its adverse environmental consequences. And why do we choose anaerobic digestion is because it is very cost effective, especially for small to medium scale, and it is also sustainable because it uses low energy and able to produce high biogas, and it has moderate efficiency, which is best for organic waste. And next, for electricity generation, we have chosen combined heat power as our process, in which it is low initial cost compared to fuel cell. And next, it is more sustainable as the heat generated will be able to recycle and use at the biodigester to reheat the biodigester. And it is also effective as it utilizes both electricity and heat produced from biogas and has an overall conversion about 90%. Next. So there are few constraints that we face when we chose anaerobic digestion. Firstly is the longer startup time is needed for good performance, especially in UASB reactor. In order to overcome this, the influent, which is the sewage, the influent we need to it need to be undergoes pre-treatment before um, going into the biodigester, in which the sewage will become more favorable for microbial growth and activity by altering its composition by pre-treatment, um, and in which it will lower the amount of particle matter through screening, grit removal, equalization tank, and primary clarifiers. And the next constraint is the presence of impurities like CO2, hydrogen sulfide, and methane. As biogas, it consists of this component. So, in order to overcome it, we need to purify the biogas by using chemical scrubbing such as amine scrubbing. Next. And this is the process flow diagrams of our plant, in which firstly the sewage will undergo pre-treatment, and it will then undergoes in the UASB reactor, and at the top biogas will be separated and stored in a storage tank, and it will then be compressed and undergoes chemical scrubbing to further recover methane, and the biomethane produced will be undergoes at the CHP system to generate electricity, and the steam from HRSG will be recycled at biodigester to heat it at the optimal temperature. And for the chemical scrubbing, we will further reduce the H2S and also CO2 before CO2 is released to the atmosphere. And before it was released to the atmosphere, we will apply scrubbing to ensure the release amount of CO2 is complies with the regulation, under the regulation. And also at the bottom of the UASB reactor, there will be sludge that we will further treat, and then we will use it as our byproduct and sell it and commercialize it. Next. These are our plant specification, in which our sewage intake was from the STP Keningau, sewage treatment plant Keningau. Based on its population, 100,000, we calculate the sewage flow rate by population equivalent times with the average sewage flow, and we get 30,000 meter cube per day that STP Keningau produces. Then we will take 80% from them, so we will produce 24,000 meter cube per day. And from the data that we have collected from RSTP Kuala Lumpur, 24,000 meter cube per day of sewage can produce 719 meter cube per day of biogas per day. And from this, we have calculated our product, which is electricity and also sludge, we are able to generate 175,000 meter cube per year of sewage sludge. And also for electricity, we are able to supply 1,800,000 kilowatt hour per year. Next.
Good afternoon, everyone. My name is Anita, and I represent environmental safety and health. So, uh, the Malaysian government has implemented important legislative, institutional frameworks, including environmental law and labor law. So, it's to promote environmental sustainable development, particularly in chemical manufacturing. And for the Environmental Equality Act, the first one is Scheduled Waste Regulation 2005. It is for all scheduled waste, including chemicals, will be stored in specified areas to prevent contamination and ensure proper safe handling procedures. And the scheduled waste will be transferred to authorized treatment facilities for appropriate processing and disposal of the chemicals and all the waste. And next, for guidelines for environmental noise limits and control, provide ear protection for workers in high noise areas, manage work shift and perform regular maintenance on machinery to limit noise exposure for workers, and it need to set up the barriers or soundproofing around the area of the equipment such as compressor, pumps and reactors that have loud noise. And for the clean air regulations, for the air quality sector, a continuous emission monitoring system will be implemented at the plant to track emissions generated from flaring or combustion processes in real time. And next, for the sewage regulations 2009, the effluent must meet the discharge limits, such as BOD must be below than 20 milligram per liter and COD 100 below 100 milligram per liter. And next, for the OSHA, Occupational Safety and Health 1994. First is Noise Exposure Regulations 2019. This is clearly marked noise zones with signs that let workers know they need to wear ear protection. And schedule hearing tests for workers in noisy areas to catch any hearing issues early on, and give workers earplugs or ear protections or earmuff to use in loud areas. And next, for the OSHA is notification of accident, dangerous occurrence, occupational poisoning, and occupational disease 2004. Any accidents, hazardous incidents, occupational poisoning, or diseases that occur during plant operation must be reported to the nearest occupational safety and health office. And monitor and document any health issues or disease in workers that may be related to exposure to chemicals or workplace hazards. Next act is Factories and Machinery Act 1997-1974. First is Building Operations and Works of Engineering Construction 1986. All electrical equipment must be properly supported on sufficient insulators and must not be dragged over nails or brackets before plant operation begins. Additionally, like equipment should not be placed on the ground unless absolutely necessary. And lastly, steam boiler and unfired pressure vessel 2017. This equipment requires a certificate of fitness which must be obtained from the state government prior to its operation. Next, for the potential risk hazards that might occur in this plant are flammable and explosion gases, chemical hazards, biological hazards, healthy and safe risks, and environmental risks. First is methane is highly flammable and can cause explosions. And also hydrogen sulfide is toxic and corrosive and harmful even at low risk. For the chemical hazards, The treatment and management of sewage typically require the use of chemicals, including acids and chlorine, that can cause burns, equipment damage, and environmental contamination if we mishandle the chemicals. The next hazards is biological hazards. During the treatment and handling process, workers may be exposed to pathogens such as bacteria, virus, and parasites, which can lead to respiratory and skin diseases, as well as other health complications if appropriate precautions are not implemented. And next is healthy and safe risk. Methane and hydrogen sulfide pose risk of toxic exposure and explosions. Gas monitoring and ventilation is very important to avoid the risk. And lastly, environmental risk. Improper disposal of untreated or poor treated sewage sludge can result in soil contamination, particularly with heavy metals or pathogens such contamination may negatively impact agriculture, groundwater quality, and the overall health of ecosystems. And next, we move on to the next part.
So for the conclusion, the production of electricity from sewage treatment has a lot of promise for usage as an energy source. So to achieve greater energy self-sufficiency, a plans could be to integrate the generation of biogas for energy recovery with improvement technique. So by examining new advancements that seek to maximize the production of biogas at a sewage treatment plant using anaerobic digestion. So through a process known as anaerobic digestion, our STP can effectively treat untreated water before releasing it into rivers, produce biogas and generate electricity. That's all from us.
Okay, thank you very much. I think Artian, I think maybe I ask your permission to start first, eh? Maybe I can start first. Is it okay, Artian?
Prof, you start first.
Yeah, sorry.
Okay.
Because I'm hurry for my
Okay.
meeting. All
Okay.
right. Okay, so first for Sophia, yeah, Sophia. So you are going to produce a slush that you plan to send it or to sell it as a fertilizer, yeah?
Yes.
So, am I right?
Betul.
Okay. So and then your plant situated in Keningau.
Yes.
Yeah. Okay.
Yes.
So all right. So do you have any targeted for example, targeted plant or agriculture for selling that particular fertilizer?
Okay. So since agriculture is the main driver of Keningau's economy, with plantation producing palm oil and rubber playing a major role. So there are chances to market our fertilizer because of the robust agriculture foundation. So from our survey, our main client for fertilizer, which is farmer and plantation owners in Keningau.
Do you have any specific plan? For example, you mentioned just now Keningau is good for oil palm as well as rubber. Are you targeted that particular plant or any other plant, any other crops?
We we don't decide.
Oh, you haven't decided, yeah? Okay. All right. So, okay, I think for the next move, maybe you need to know what is the quality of that particular fertilizer. So you can actually targeted what is the best crop for that particular fertilizer. All right.
Okay.
Okay. Now, Ariana on process. Okay. You mentioned about USB, aflo anaerobic slash bioreactor. Okay. Aflo anaerobic. Okay. All right. So my question is, when you produce the sludge from that anaerobic aflo anaerobic digestion, okay, you mentioned that one of the problem is low startup, isn't it? Low startup, yeah. Okay, so how you are going to overcome that problem for the low startup?
So, thank you, Prof, for the question. So, for the lengthy startup at the biodigester, I have done a research about this, which is we need to undergo the sewage through pre-treatment, in which this stage will involve microbial colonies establishing and adapting to the reactor's unique movement. Um, we need to prepare the sewage to become more favorable for microbial growth and activity by altering the composition of the sewage through pre-treatment, in which we will remove the solid and also any contaminants before it is injected in the biodigester. That's why we will implement a grid and also um, equalization tank and also screening and also primary clarifier.
Okay, are you planning to buy the microbes from overseas, or are you going to develop your own? What's your plan? Or do you have any plan for that?
We are planning to buy it, but then it will eventually affect our costs. But then to ensure the more efficient, I think it's better to buy.
Okay, do you include that particular cost in your economic study?
Not yet, no.
Okay, okay. So you better to think about that, yeah. Okay, all right. Okay, thanks, Ariana. For Agneta, okay, you mentioned about biological risk, yeah, which is I think is critical in sewage sludge. So, do you have any idea what will be the problem for the sludge? I mean, the sludge risk, okay, after the anaerobic digestion. Anita, do you hear me?
Yes.
Okay, after anaerobic digestion, you produce sludge, isn't it?
Yes.
Okay. So what is the potential biological risk for that particular sludge? Did you ever check the pathogen, the salmonella, the E. coli from any literature, something like that?
So the risk for this is it can cause the gastrointestinal disease and food poisoning and infections if humans come to contact with contaminated slash or consumed crops grown in slash treated soil.
Okay, what I mean is, did you ever come any literature, okay, on sludge that is derived from UASB? What you mentioned to us is a very general one, but I want to see the particular study since now you are select USB. So is there any study, okay, for those sludge that come from USB is having a risk of pathogen or not? Do you come across any study on that?
Still, we're doing this research and researching for the review, doctor.
Okay, okay, thank you, Anita. I think please consider that, yeah, because now because you already you have chose the particular component for your system, so it is better for you go for a very particular case, yeah, case study, which is the sludge from USB. Yeah. Okay, and then Hazmira. Okay, do you compare your, for example, your economic analysis with others STP? Okay, for example, with from Kuala Lumpur STP, Pantai Dalam STP plant, for example. Did you compare your cost? Because I think they also produce biogas. Do you have any idea on that? Or for that STP, you don't compare about the cost? Yeah, I think the cost is available, isn't it? You actually you can check the cost, the land area, so you can compare. Okay, at least you got some idea. All right, just comparison for that, yeah. Okay, thank you very much. And now I pass to IRTN. So I'm very sorry, I need to leave now. So before I leave, I would like to thank IRTN for coming to UMS, join us, and helping the student. We are really happy you come here and help our student, and hopefully we can have a collaboration together in the future. Okay,
Okay,
thank you,
thank you.
Ayatan. Okay,
Thank
bye.
you.
Bye. Bye.
Hi everyone. I go through your objective. Can you hear me?
Yes.
Okay. My name is Tan. I have comment your. I have go through your presentation. I have some comment. Please take note some of my feedback for your improvement for your report. So I will roughly go through from the beginning until end of your presentation. Okay, first of all, saya cakap campur bahasa Melayu dengan Inggeris. Tadi ada yang objektif sana, ini yang objektif kamu cerita SSP need to generate 70% of Sabah base load power requirement. So this one, kamu ada refer literature review ke ataupun yang solid reference newspaper?
Ya, newspaper. Yang ni SESP sendiri yang macam wawancara dalam newspaper lah.
Okay, so that's good. So you need to quote it because kalau kamu mention begini kan, I thought ialah macam general punya. Tapi kalau yang betul-betul fake, so you need to quote SSP punya artikel. Maybe you will mention according to the statement released by SSP date pira-pira beginilah to convince the audience yang kamu ada ini fake lah. Secondly is the process flow diagram. The process flow diagram you need to show mass in, mass out. Okay, yang ini sudah okay, location okay. This one tiada. This one, PFD. You need to show your process flow diagram for every each unit operation. You need to show mass in, mass out. So like sewage ada apa? So masuk ini equalization tank, berapa liter air masuk, berapa sludge keluar. So you need to mention dia punya feed and the product for each unit operation. Okay, until the final product is the sludge and the gas. Your gas is the H2S kan dengan CO2. Itu mau mention dalam itu flow diagram lah. So saya tengok di sini hanya ada CO2 saja. Dia ada HO2S. Dia ada sludge. Right? Sludge. Saya tidak nampak sludge pergi mana ni. You didn't mention your sludge. Because you say you want to convert your sludge into fertilizer, you want to make it into wearable product. So itu sludge punya proses di mana? Tiada kan? Because your objective is to turn your sludge into a fertilizer. So you need to improve this flow diagram to include the sludge. Faham? Okay, another one is you talk about UASP is very efficient. So you need to do cost analysis and sizing for the UASP. What I mean is cost analysis and sizing is kamu perlu kira berapa dia punya length, berapa dia punya area, berapa size, and then ada dia punya accessory, macam dia punya inlet valve ke, dia punya pump, all this, you need to come out the sizing, cost analysis to justify it is cost effective among your other option. Okay, because now you just say, I as a buyer, I'm the investor, saya mau tahu, not everyone got 70 million US dollar. So, saya mau justify, kenapa kamu mau begitu banyak capital? Macam contohnya equalization tank, I want to know how big volume of the tank, and then your reactor made of stainless steel, jenis stainless steel apa, sizing dia, so you need to break down to cost analysis. Okay, another one is do power analysis for CHP. Just now you mentioned CHP is efficiency, right? Don't just mention efficient, you need to say CHP lah. Okay, I will go very fast. Tadi talking about Dr. Abu mentioned the risk. Your friend talking about environment. Yang tadi itu environment punya, sorry I have to say, itu sangat general. Yang ini environment, safety and health. Sangat general, tidak berkaitan dalam plant design. Kalau saya as an investor, saya tidak tengok ini. Saya mau tengok sewage, how you tackle your sewage. Like doktor cakap, dalam kamu plant design, kamu mau proses ini such. So I'm the investor, saya mau tahu kamu buat ini kirang, macam mana kamu handle ini, dia punya environment safety risk. So you need to know, go through literature review, adakah dia punya biogas sangat membahaya, kalau biogas membahaya, apa kamu punya action ataupun installation to capture itu dangerous gas and sludge. Ini proses yang kamu mau tengok, bukan yang pasal noise. Effluent okay, water quality okay, tapi noise dengan tidak berkaitan dengan ini factor machinery. This is too general, no need put into plant design. Okay, so if you say itu sewage atau bau, so you need to installation air filter, so you need to sizing air filter tu dikirang, itu air filter jenis apa, activated carbon ke, berapa besar ke, simpan di mana. Inilah kamu punya environmental safety and health you talking about. Okay, and then some mistake is your yearly production rate of electricity. I don't think it's correct, so you need to check back. And then it is impossible, I go through your PowerPoint, you say 30 hari buat 2 jam maintenance kah? Cannot. Kamu punya calculation tu. For a plant, normally 1 tahun, they have a preventive plan. 1 tahun mungkin ada 2 kali, 8 jam contohnya. Macam di sini kan OJI, dia ada 8 jam punya maintenance. So they will calculate 8 jam maintenance, berapa shutdown. So itu masa tu 2 hours per day is not practical lah. So itu calculation perlu kira balik. And then please do calculation for your sewage, sludge and electricity generated. And then how do you come up with the equipment cost? Tengok balik. Because kalau saya tengok 6385, 699 ini US dollar kan, better convert in Malaysia ringgit lah. Susah mau tengok, macam doktor cakap, you got the cost kan, kau boleh compare, you buat comparison in Malaysia market value. Okay. And lastly, please they do the economy analysis. And then ada satu lagi, saya punya komen, under regulation, what is the safest level CO2 can be released to the environment? Ini. Sebab kamu cakap body disease to the environment, right? You want to produce fertilizer. So you need to check DOE website ke or literature how safe CO2 can be released to the environment. Okay. So your conclusion juga tidak reflect kamu punya objektif. Kau punya objektif ada dua ni. Buat fertilizer, buat clean energy, mau sell energy to SSP. But I don't see you reflect your conclusion. Your conclusion you sangat general. Need to redo it lah, this thing. Okay, that's all for me. Now I would like to return to the Miss, siapa leader kamu? Ariana kah?
Yes,
Okay,
Miss.
okay.
Um, uh, since I have a question,
Okay.
kan kami punya apa tu? Yang 17 payback time is quite long.
Ya, kalau saya rasa impossible.
So do you think should we increase the production of our?
Yeah, actually ya lah, because your calculation wrong already from the production. Jadi kamu punya production sudah reduce. Jadi kau punya profit pun kurang. Jadi mau payback pun take a longer time.
Yeah.
Okay. Jadi you need to think because kamu tulis di sana 1 tahun kirang kamu hanya jalan 330 hari kah? Saya tengok kita 1 tahun ada 365 kan. So maybe you say in a year you got a major shutdown for 16 hours. You need to increase production because normally Roji you will run 24 hours. You need to kira itu time because time is quantity, rate over time, right? Begitu kira lah. Okay. Yang tadi ada satu lagi itu land. Land you can compare, and then variable cost of production, like doctor say, if you are planning to buy the microbes, you need to put the microbes raw material, harga raw material tu dalam berapa tan untuk 1 tahun tu, itu pun cost masuk dalam kamu punya variable cost. Ship, and then seraj, kalau ada transportation kan seraj, itu pun mau kira juga. 1 hari berapa trip lori, contohnya kau pakai lori lah, because some people selling the sludge to your logi. Okay, you need to calculate. Tapi dalam itu beginning yang pendahuluan, kawan kamu ada cakap, I notice, she say we cannot direct, you need to save cost reduction in the pipeline. Jadi kamu direct discharge itu sewage. Actually ini lari dari objektif kamu. Di Miss Sofia kah? Kamu ada mention kenapa kau choose itu location dekat sungai, sebab kamu mau release treated water to the river. Actually salah tu. Kalau ikut regulation, you cannot discharge anything to the river. We have to contain it in the lagoon. We call lagoon. Jadi in the lagoon, kau ada sludge kan? Itu sludge, kamu pergi tickling process, ada sludge, kamu buat fertilizer. Then itu water tu, effluent tu, you need to treat until itu ikut itu DOE requirement. Then we call treated water. Berapa BOD, berapa pH yang safe to release to the environment. It's not because the pipe cost reduction lah, tidak ngam tu. Okay. Kamu mesti ingat kamu punya objektif ketiga tu. Okay. Dalam buat ini plan design lah. Okay. So yang environment tu di redo lah. Sebab itu ialah general. Talking about factory, machinery, tidak berkaitan. So you need to think about sludge, right? apa dia punya environmental punya risk, dia punya hazard. Kamu buat itu hazard analysis. Okay? Ada apa-apa soalan lagi?
Yang pasal shutdown tu itu per month ataupun macam mana tu?
Normally macam sini Roji, kami 1 tahun ada 2 kali shutdown. Satu, tapi bukan hari yang sama. 1 tahun ada 2 kali, contohnya February and Oktober. Ada 6 bulan jauh lah. So 1 hari kita ada 8 jam shutdown. Jadi semua department akan buat maintenance work lah. Begitu. Jadi contohnya kamu mau shutdown itu production, jadi kamu punya calculation is 365, kamu minus 2 hari lah, because you allocate 2 hari untuk maintenance. You mention dalam kamu punya calculation, assume 2 days for offline for maintenance. So working, how to say, number of days adalah 365 minus 2 is 363. Jadi kamu punya rate tu bahagilah 363 hari. Jadi kamu punya calculation 330 hari tu tidak ngam tu sebab 1 bulan uji tidak jalan. Mana ada profit ni? Okay, impossible lah. Makan kangkung kita ni. Okay.
Okay. Thank you, Madam, for your
Okay.
assist. I think that's all. And can we take photo before we end this
Okay, can.
session?
Okay. Okay, thank you.
Thank you, Madam.
Okay, good luck to your study. Okay, see you.
Thank you.
Okay.